They were talking about the Long Island Sound, correct?
Yeah.
Okay, so guys, let's do a little review. What do you remember about the Long Island Sound? Some things you can tell me about it.
It's an estuary.
It's an estuary. Remember the definition of an estuary.
It's fresh water combined with salt water.
Okay, it's an area of brackish water, mix of fresh and salt water. What else about an estuary?
That animals come in the tide to lay their eggs.
Okay, and why do they do that?
Because they think their eggs are going to be safer.
Okay. Can you guys give me a reason why it might be safer in the estuary than out in the ocean?
It's almost completely surrounded by land.
Okay, so it's partially closed off. What land areas are surrounding the Long Island Sound?
Long Island.
Okay, we have Long Island. What else?
I think that's part of Connecticut.
Connecticut.
Massachusetts.
Massachusetts. So I have Fisher's Island. And farther to the north around the Rhode Island area with Block Island that kind of serves the northern border to Long Island Sound. So it's a partially closed off body of water. Does that mean it's going to be really deep like the Atlantic is?
No.
No.
I mean, it's like 60 feet down.
Average depth in the Long Island Sound is about 60 feet. So it's not that deep. So does that mean a lot of big predators can get into the Long Island Sound? Yeah, it's sort of a safe thing. That's why animals will come in here to nurse their young, lay eggs. Animals go out in the marsh to do the same thing. Safe there. Okay, so as scientists, what are some things we do to learn about Long Island Sound, learn about the water, find out the health of the sound, what kind of measurements we can do? Okay, so as scientists, if you guys were scientists coming out to the marsh, or coming out to the Long Island Sound here, what are some measurements we can make to learn more about the sound? Okay, we can measure the temperature of the water. What else? The depth, we can measure how deep it is. So, well, you can more see the tide by looking, but that's partially also by depth as well.
Measuring the animals that live in the Long Island Sound.
Yep, that's one. Another thing about the water, though. The quality of the water. What other water quality type of measurements can we do? We can measure the salt content or the salinity of the water, how much salt is in the water. Anything else?
It's fresh.
How much? Yep, the salinity of the water tells us how much is fresh, how much is salt. Some other things we could do, things like measuring light in the water, sunlight depth. We can measure how far down the sunlight's penetrating. We can measure the amount of oxygen, dissolved oxygen in the water. So, even though it's water and fish breathe the water, they're breathing the oxygen out of that water. There's still oxygen in water. So today, what we're going to be doing for the next few minutes, we're going to do a couple of those measurements. We're going to do the salinity measurement. We're going to measure how much salt is in it. We're going to measure the temperature of the water. But if we wanted to get crazy, if we had more tools out here, we could do things like UV and light. Things like that. We could do a dissolved oxygen test. But that stuff's a little bit crazy. I don't have the materials for that that I could bring out here. Yeah.
Why would it be important to know how deep the sunlight is?
Because sunlight, just like other life on land, most animals need sunlight to survive, and so do plants. What is that called when plants use the sunlight to make energy and oxygen? Photosynthesis. Yep. So just like the grass on land and the trees, the plant life in the sound needs sunlight too to do photosynthesis. Yep.
Can the salt block out the sun if it's really thick?
Probably not. Not out here. There's not enough salt in it. But some things can block out the sun. The sound is pretty murky. There's a lot of other stuff: sand, sediment, there's rocks, things that can hide the sun in places. For the most part, though, where we are, the sun measurement's not gonna really do much for us in the sound because, like I said, average depth's about 60 feet. Sunlight will penetrate a lot farther down than 60 feet. Yep.
Why is it important to measure the temperature of how long it is?
Well, part of that is because it can let us know the health of the animals that live in the sound. In New England, it's generally a colder water environment. The temperature of the water can make different important differences for the animals and the plants that live here. Some animals rely on heavily salt water. So animals that live outside of the sound in the ocean, some of those animals need more salt or are used to more salt in their body than others. Animals in the sound, they need to be able to survive in both freshwater and saltwater environments. So we want to make sure we don't, if the water's really salty in here, then that might mean there's not a lot of fresh water flowing in. That might mean the rivers are dried up, or we're going through a drought, so there's not a lot of fresh water or rainwater getting into the sound.
Okay. Yep. I heard that bullfrogs can also survive in both freshwater and saltwater. Is it possible that they could be eating?
Maybe in the marsh. I'm not 100% sure about that. That's a good question. They probably wouldn't be able to survive out in the sound itself for very long. But yes, some animals, as long as there's fresh water, they can maybe survive for a short time out here. So, we're going to get started. I have a bucket of water here. So, in this bucket of water, this is water from the sound. If I was to measure the temperature of this water, do you think it's going to be warmer or colder than the water out in the sound?
Warmer.
Warmer. Why is that?
Because it's been out.
Yeah, because it's sitting in a bucket. Yeah, it's a lot shallower. Guys, do you remember what we talked about at the very beginning? Yes, thank you. So, you have sand in your hand, please drop it. Thank you. Okay, so this is going to be warmer than the water out in the sound because it's been sitting in this bucket. It's a lot shallower. There's not as much water here. The sound is constantly moving. So there's water constantly churning and churning. So the water at the surface of the sound is going to be warmer or colder than the water down at the bottom?
Warmer.
Warmer. Why is that?
Because
Yep.
when the deeper you get, the higher the air pressure, and it makes it colder, and the sunlight hits the top before it goes to the bottom.
Yep. More sunlight affects the top, the surface of the water than it does as it goes down because less sunlight reaches the depths. So it's going to be colder down underneath than it is on top.
Does air pressure have to do anything with it?
I don't think so. Okay, so who wants to measure the temperature of this bucket for me? Okay, so you hold that in the water for probably about 10 seconds, then tell me what the temperature is. Just give me a roundabout estimate. 72 degrees, okay. So this bucket probably hasn't been sitting out here for very long, so it's probably not all that different from the sound. I'd probably give it about 5-degree difference, especially because we're measuring it, like we said, right on the beach here where it's really shallow. We go out a little bit further, probably like maybe a quarter mile out there, it's probably going to be a little bit colder. I would say the depth of the average temperature of the sound this time of year should be in the 60s. So right here on the beach, especially in low tide, this water's sitting, it's not moving, it's just letting the air and the sun get to it. So it's going to be a little warmer, so 72 degrees, that's pretty warm right now. That's actually good swimming weather. What about the salinity? Is the salinity in this bucket going to be different than the salinity in the south?
No.
No, it shouldn't be. Shouldn't be at all, because I don't see anyone dumping extra salt in this bucket. So it shouldn't be any different. Now, compared to the ocean, the Atlantic Ocean, is there going to be more salt water? Is the salt level in the sound going to be higher or lower than in the ocean? It's going to be lower because of the fresh water that mixes in. So, the average salinity in the ocean, I believe, it's around 38 it's between 38 and 40 parts per thousand. We measure in parts per thousand, or PPT for short. So, very general meaning for that is, say you have 1,000 buckets, just like that, filled to the top with water. 1,000 buckets, all in a line. 40 parts per thousand means that 40 of those buckets will be full of salt. The rest of them will just be filled with water. So 40 out of those 1,000 buckets are filled with salt. That's how much salt is in the ocean. So that's just kind of a roundabout, simple way to think about that measurement, how we use that measurement, parts per thousand. So 40 parts per thousand.
So then that's like 4 out of 100, which is about 4%.
Sort of, yeah. If you want to do the math that way, you can do it. We just use PPT, that's our unit of measurement, parts per thousand. So that really, when you think about it, isn't that much. It's really not all that much of salt. It seems like that to us if you've ever swallowed salt water. It tastes disgusting.
Yeah.